Okay, so in this question, here's my quadratic here, and I've identified my values of a, b, and c. So a is the value k plus 2 in front of the x squared, b is 4, and c then is k plus 5. And the question says that given that the quadratic equation has no real roots, show that this inequality is true. Now, if there's no real roots, so given there's no real roots, of course then the discriminant is negative, isn't it? Okay. B squared minus 4ac is less than 0. So if I substitute in the values, then b is 4, a is k plus 2, c is k plus 5, okay, and that's less than 0 then. So simplifying this, I get 16 here. The bracket then multiplied out, I get k squared plus then 5k plus 2k, the outers and inners, plus 10 is less than 0. This then bracket then becomes k squared plus 7k plus 10 is less than 0. If I multiply out that bracket then, I get minus 4k squared minus 28k minus 40. And then simplifying it, now when I simplify, I'll put the k squared first, so it happens to be minus 4k squared minus 28k, the k next, and then the constant at the end. So 16 and minus 40 becomes minus 24. Less than 0. Now you see with the quadratic here, I'm not happy when there's a minus in front, okay, so we're going to divide through by minus 1, okay, to change all the signs, but also you'll notice 4 is a common factor, so we can divide through by 4 as well. So why not do that in one go? So divide through by minus 4. So if I divide this by minus 4, so minus 4 divided by minus 4 is just 1, so you just become k squared. Divide this by minus 4, or minus 28 divided by minus 4 is plus 7, okay? And then minus 24 divided by minus 4 is plus 6. So we divided by 4 and the signs have changed. But what's important to remember, when you divide by minus, okay, the direction of that inequality is going to change. Okay, it's really important to remember that when you divide by negative. So now it's greater than 0, and if you notice then we've got exactly what they've asked for in the question, okay? Then it says find a range of values satisfying this inequality. So now we need to solve this, right? We need to actually work out what values of k make this quadratic greater than 0. Okay, so to solve it, right, we'll consider the critical points. Okay, what I mean the critical points, the actual case where the quadratic is equal to 0. Now I know we want to solve it where it's greater than 0, okay, and we won't consider where it is actually 0, we don't want that, but if we know what those points are, okay, then lovely. So if we factorize that quadratic, okay, then we'll work out the values of k where the quadratic is 0. So k plus 6 is equal to 0, or k plus 1 is equal to 0, which means then we get k is equal to minus 6, or k is equal to minus 1. Okay, so those are the two solutions there. All right. Now that's where the quadratic is equal to 0. Okay. But of course, we're not interested when it's equal to 0, we're interested when the quadratic is greater than 0. So let's identify where it's equal to 0, minus 6 and minus 1. Okay, and we'll draw a quadratic curve. Okay, so these are the critical points here, all right, where the quadratic is equal to 0. But I am interested in when the quadratic is actually greater than 0. So it's greater than 0, the curve goes this way, and the curve goes that way. Okay, that's when it's the curve is greater than 0. So k in this case will be greater than minus 1, or k will be less than minus 6. So it's either greater than minus 1 going that way, or it's going to be less than minus 6 going that way.